So this video is for the intro to the MEP class. First we're going to talk about what is MEP, then we're going to talk about where it's used, then we're going to take a look at a set of MEP drawings. So first, what is MEP? MEP systems are essentially the central nervous system building, responsible for the creature comfort features of a structure, and it's what makes the building livable and pleasant to be in. So first is mechanical. Mechanical design elements of the building are the heating and cooling loads, which help make life more comfortable. Mechanical is responsible for the heating and cooling of a building, the humidity control, odor removal such as exhaust fans and kitchen hoods, as well as outside air delivery. Next is the electrical. Electrical systems keep the lights on, keep the devices powered, and all the other systems running. Lighting design is a crucial component to the engineering process. Electrical takes care of the lights, the power, and conveyance, which is essentially moving throughout the building. And lastly, we have plumbing. This is what circulates water and waste throughout the building. It provides fresh water for drinking and cleaning, and takes the storm and sanitary wastewater away safely. So they are responsible for hot and cold, clean water supply, liquid and liquid waste removal, and also the fire suppression systems. Next, where are modern MEP systems used? So basically, any building nowadays, you're going to have MEP systems. Commercial, industrial, and government buildings. This includes offices. So in offices, you would have your power outlets, your lights, your supply air, so your air conditioning and heating. Conference rooms, same mechanically, so the heating and cooling, as well as any TV or teleconference. Then in the kitchen, break room, restrooms, and showers and gyms, these will have the same mechanical, so the heating and cooling, same electrical outlets, lighting. This also includes the plumbing, so you have your kitchen sinks, your restrooms, your water closets, your sinks, showers, drains, and then lastly, server rooms. Those are pretty heavy mechanical, so cooling as well as power for the servers. In residential dwellings, so think about your house. Think about some MEP systems in your house. You have your outlets for power, TVs, lamps, kitchen equipment. You have your gas. So if you have gas in your house, you have your stove, you have water heaters, maybe the heater in your attic. And then plumbing, you have all of your sinks, your restrooms. If you have a sprinkler system, all of that falls under the plumbing. Modern MEP systems were a major contributor to the creation of high-rise buildings. Lighting inside, water, removal of water waste, that was a big one. As the systems have become more efficient, the higher and more complex these buildings have become. We have some citywide MEP systems. It's pretty common. People would know about the modern water treatment plants that provide drinking water, and then as well as the wastewater that takes the waste away. Here are a couple examples, and you can look at the PDF if you want to actually take a closer look at these. City of Austin water treatment plants, as well as the Albert R. David plant that provides drinking water. For wastewater, they have treatment plants, Austin Water Utility Plant, and the Walnut Creek plant. Not a lot of people, though, know about the HVAC citywide utility. Downtown, they have a series of pipes that run underneath the streets. They deliver cold water to run these large towers, air conditioning, and heating systems. Basically, they pump cold or hot water to the buildings, and these buildings pull out the energy from the water and use that for their air conditioning systems. We look at, this is the downtown Austin chilled water plant. A few different big plants around the downtown area, and deliver cold water to high rises. And lastly, we have modern power generation. So Austin has mainly natural gas power plants around. So here's a list of power plants. So you have your Decker Creek, your Fayette Power, Mueller. So you see most of these are natural gas. You also have a Fayette Power, you have coal. So these are all different power plants that serve the Austin area. Once again, links are in the PDF provided in Lecture 1. Next, let's look at the sections of an MEP drawing set. So you have the mechanical. You'll start off with the symbols legend. This is pretty typical through all disciplines, commercial, architectural, structural, everything. Then you'll have a schedule sheet. You have floor plans showing the duct layout. And lastly, you'll have details. And next, in the electrical set, you'll have the same symbols legend. Then you'll have a lighting floor plan, power floor plan. You may have an HVAC power floor plan, depending on how busy the power floor plans are. Could have a special systems floor plan, which is just a fire alarm. You'll have what's called a one-line diagram, which is essentially a diagrammatic layout of how the panel boards and everything is connected. You'll have the panel board schedules, and then you'll have details. Lastly, you have plumbing. Once again, you have the symbols legend, and you have the plumbing schedules showing fixture types. You have your plumbing floor plans. Then you'll have plumbing risers, which is essentially either 2D or 3D isometric view of how the plumbing is routed. And lastly, you'll have details. Lastly, let's take a look at a set of MEP drawings. We're going to start off with the electrical. Here's a symbols legend. You should have all of the symbols that appear in your drawings be defined on this sheet, as well as abbreviation terms and general notes. Next, we have a schedule sheet for lighting controls and lighting fixtures. So lighting controls, this is essentially how the automated systems are working nowadays. Due to energy requirements, you have to have controls on all of your lighting. And this is just how we represent that. And then we have a lighting fixture schedule. For each fixture you show, for each fixture on a floor plan, you would need a tag, and the tag refers back to your lighting fixture schedule here. This is a lighting floor plan. So for power, we need to show everything that's connected, and then this goes back to the panel. Panel is a distribution center for power. You have one in your house, maybe in your garage or in a closet. It's that that gray box that you open up and you have the breakers in. That's going to be a panel. So this goes back and it shows you what panel it goes to and kind of how the lights are laid out. We would go through and we would need to show each light according to what the area is, and there's different calculations for how much light's needed in certain areas. Okay, and we get into the power. So this is all of the outlets and receptacles and data, floor boxes, how everything's wired. Just like the lighting, it goes, you show a home run back to the panel and what spaces it takes up. Modular furniture. We also show conduits. Conduits are essentially pipes for electricity runs and wires. Printers. So essentially, we have to coordinate with the architect and the client what equipment needs to go in. Do they need special requirements? We have to power all of plumbing. So this is a water heater, and so we have to essentially get with plumbing and mechanical and the architect and the client and see and make sure everything is power and there's enough space electrically for everything. Kitchens, that's a big one that need a lot of coordination. Coffee makers, ice machines, things like that require a lot of power. So this is level 6, 7, like I said, so it's 10 floors. And then on this job, we had HVAC power. So this is just powering the mechanical units, the air conditioning and heating units. Like I said earlier, depending on the density of the floor plan, if the power was very light, sometimes we'll show the HVAC power on the same sheet. It's all about legibility. Okay. Then we have the fire alarm systems. So fire alarm devices, initiation devices, relays for the shut down the units. This is where we have to show everything here. The firefighter phones, everywhere required by code. And we will go into all of these systems in more detail when we get to each discipline. And in this particular set of drawings, we had to create a series just for the conduits. I had a whole lot of special conduit needs, going from this is a floor box, you plug laptops and whatnot into, going into junction boxes for TVs, and flat screen TVs are mounted on the wall here. And so we had to really detail out a bunch of conduit for this particular client, just because it's a lot of technology needs. And we do have to coordinate with structural. So you see these gray dashed lines here. These are where the structural beams were going through. And you have to be careful penetrating structural beams. So you really want to try to avoid it as much as possible. So this was us trying to show where to penetrate the floors. Once again, more structural penetrations. It's a lot easier to place as you pour versus drilling it after it's been poured and dried. And this one is actually a dimension plan, from each grid line to show where they had to put these sleeves. And then later it would go back and actually run the conduit. This is an elevation. Level 5 is the top of the garage, and we had to make sure that we kept clearance in the garage. So as cars coming up, we need to show where the conduits are and make sure everything fits, the big pool boxes and everything. Next, we have enlarged plans. So this is all the electrical rooms, showing all the panels, and then disconnect switches. So this is basically how you turn power off to certain panels. You have your transformers here. More enlarged plans of labs. And your detail sheets, so a lot of these are standard details. So different equipment, how lighting control is wired. This was a fit out, so essentially that means that they built the shell building first, and then this client came and rented out certain floors. So you see that there's a lot of grade tone or half tone stuff here. That basically means it's existing to remain. This is a diagram of how the power is run throughout the building and what's connected to what. Now this one is actually the emergency one-line diagram. This is the standard power. So you have what's called a bus duct. So it is basically a solid copper bar running through the building that carries a whole lot of electricity and is the main distribution for all of your sub panels. Then you have your panel schedules. So I talked about panels a bit earlier about how you probably have these in your house. You may have only one that's 30 or 42 spaces. That's kind of common. In a big building like this, we have huge panels. That is 120 circuits per panel. And you look at here, so this is your level 6 low voltage, so that means 120 volt panel. You have one for level 7, level 8, and basically everything is labeled what it is and kind of the mechanical equipment and how many receptacles and everything on that circuit. More panel schedules. Then we look at the mechanical. So this is once again the symbols legend. Everything on the drawings should be on this schedule. So if the contractor is starting to building something and they see this symbol, let's go look at the let's go look at the symbols legend. That's a ceiling grill or supply. And then schedule sheets for mechanical. So you have each unit name, basic unit information, your electrical information, the heating information, and then an actual part number here. And there's just different types. So these are FPTUs, so fan power terminal units. You have VAVs, which are variable air volume devices. And you have this is a lot like the light fixture schedule, but this is the diffusers. So the diffusers are the pieces in the ceiling grid that air comes out of. And this basically tells you, what they look like. The CFM, that's the cubic feet per minute range. That's basically how fast or how much air comes through. Inlet size or different connection sizes, and then actual part numbers. And here's a mechanical plan. So it really starts here in the middle of the building. This is the AHU, or the air handler unit. This is what blows the cold air or hot air, depending on the time of year. So this was all existing. That's why it's halftone. Then notice that it comes out into this hallway and then goes left and right, and then that's where we connected to. That's where the dark lines pick up. So we show the trunk running around, and then the sub feeds coming off to each unit. So here's a fan power terminal unit. So basically it's controlled by this thermostat right here. And then if this area gets too hot or too cold, it'll tell this thermostat, or it'll tell this unit to come on and either heat or cool the area. You have your units, controlling. You have your fan power terminal unit here. Then you see your diffusers here. So this is an open ceiling, so it dumps out into round diffusers underneath ducts here. Cool this area. And then notice there's a lot of attention paid to the exterior of the building. So really most of the heat load, your heat gain nowadays, referring to summer anyway, comes from sun coming in to the windows and basically heating up these areas. There's a lot of attention paid to the direction that the building is and how much heat is coming through coming through the windows. So basically there's a zone here. You notice this fan power terminal unit is just controlling, this thermostat here, just controlling this area. So it's independent from back here. So if there's a lot of sun coming in here, it'll add cool air here, and it won't freeze the people out here because this is a different unit. And your diffusers, I refer back to your diffuser schedule. So we had H right here. We go look at H here. We can see that it's a metal air 4-foot slot diffuser, which are essentially just long, narrow diffusers that are either mounted right above the glass or in ceilings. Once again, all 10 floors are all 4. Okay, then you have your controls. So your HVAC, they have some pretty complicated controls as well that measure temperature, humidity, basically sequence of operations. And in this particular building, and in most high rises, you'll have a what's called a pressurized stairwell. This is in case of emergency. Essentially, they pump air into the stairwells to keep the smoke out. So this is how they control the air going into the stairwells to pressurize those in case of emergency. And then we have the mechanical details. So once again, a lot of these are standard details. We do have to edit the details some depending on the job. If you need to do some sort of special mounting of diffusers or anything, this is where it would be shown in the details. Then we get into the plumbing drawings. So this starts actually on level 5. So just like the conduit drawings, you run a lot of plumbing underneath the floor and in the ceiling. So they had to create a basically an underfloor plan here, showing where the stuff is coming up. And we'll go look at level 6 now. You have your plumbing here. So the not in contract, that basically means that this stuff was done under the shell building, and that we're not touching this. So this is what we're adding to the existing. A couple of water fountains, some drains. You have this hatched in area here. That basically just means that this refers to a detail. So we'll go to detail 6 on P201, P2001. It'll be this area. So same things, the kitchens. So just like electrically, there's a lot of attention paid in the kitchens, and if you need to create a large plan to to better show what's happening in there, then you can definitely do that. Had some labs in here. I believe this is all compressed air. Yeah, CA, that's compressed air lines. So plumbing isn't just in charge of the water and waste. You don't have to do any sort of compressed air, or if it's medical, any sort of gas or anything like that. Okay, get to large plans. All right, so here's the galley area, or the kitchen area for level 10. So you have a water heater, you have your sink. You notice that this is, just kind of looking at this, is kind of hard to read. Really, the plumbing relies a whole lot on the riser diagrams, which I'll show you here in a second. In conjunction with these, so the contractor will come in here and see all this stuff, and then they'll go and use that in conjunction with the riser diagrams here. They'll go find the same area and say, okay, well, this line was overhead and this line was underneath. So it's a lot of kind of back and forth for the contractor to figure out exactly what's going on. Here's my riser diagram. This is for the galley area. So normally they try to stack all of the restrooms and the kitchens so that it makes running these lines a whole lot easier. This one done in Revit, so it's a lot easier to kind of build these riser diagrams, because you have your 3D space to actually create these pipes and run them in walls and overhead underneath, and then you can just pull a view, remove everything except the pipe, and then set your visibility to look like this. Whereas AutoCAD, the designers really have to think about what's overhead, what's underneath, and do a diagram. Versus Revit, you just draw it in 3D and set a view up. Basically makes it for you, and that's when you do your tags and your your call outs for what's what. That's it for the modern MEP drawings, as well as the intro lecture.